Yeah. Your phone, you Mojana just my XX young channel. Manu phone you of no even go away. Small come options are with your cash in the catch in the Kukashi with your Mazima Yok. Who did you complete what your camera did for my Mabakashi, you Mazima. Baiga kareti siaget imata uflash au masima yako. Ukabanga start moja save madani. Save mabita basi. Ingole final analyze. Masima. Bora kuenda mambo kwa jao sasa. Ndio wanaendelea tumeisina tunaweza kukabla. Sure. Kuja ndichane kwenye kuina mimi hapo. Bwana ndiye ndio nyanya. Chezi basa hapa leo. Yambi kuti tuone kuti tutakuzokutika mudi muzivangaza piwa science. Sikasi zaidi basi. Hizi ndi zaidi. Ai ngali ngurungani. Hizi tunataka. Au tena kama ya mzao. Acha. Mabroka mzungadidi mateke maboga mgarawa kwenda wewe ora nimenya kupuzi sawa kake kupuzi sema ngera ari mazikine kwa meno banga kadi kutoni jamaa ndio system anaita usanka. Okay, so I think today we are going to start our lectures. They'll be going kind of slow because I don't have much time. So I'll start from the first topic of networking, which is networking topologies. So we'll be going step by step, topic by topic, until the end. I hope you'll be with me. So I think our first chapter is about network topologies and technologies. So what do they mean when they say network topology? Topology is like the way your network is arranged physically, how people see it. See? So technologies, what technologies are you using? What cabling are you using in the network? So the objectives for this topic are to recognize the following logical and physical network topologies from a schematic diagram or description. So as it is here, we have what? Bus topology, star topology, mesh topology, link, and what? Wireless. So the second objective is to specify the main features of what? 802.2 LLC, 802.3 Ethernet, 802.5 token array, 802.11b wireless, and FDDI networking technologies, including access method, topology, and what? And media. Going through those things as explained above, linked Carl Mose. So this is just a word, a chapter pretest. After this chapter, we'll be going through these questions. Like one, what are the primary advantages of bus network topology? What is the typical cable type used with a star topology? How does the network react to a cable break with a bus topology? What is the primary goal of building a mesh network? What is the most common type of ring network? What is the connection method used by Ethernet? And what are the below questions up to 10? So optical so network. So a local area network, a LAN, is basically defined as two or more computers connected by a structured wire system for the purpose of sharing resources and files. So the main thing about networking is like sharing what? Resources and what? And files. That's the main thing. That's it. There's nothing more. You share resources and what? And files. You go on the internet. You take what? You take files and you share resources. That's it. You do what? You do WhatsApping. You share resources and what? And files. That's it. This is networking. All of that is what? Is networking. So in this chapter, we explain the various structured wire systems that the network engineer will deal with during the course of their job. Wireless local area networks are becoming more and more popular, but even these devices rely on some amount of physical wires in most cases. Throughout the history of the RAN local area network, various techniques have been deployed to connect the end user device together. Overall, the routes of these cable systems are what? The network topologies. So our network topology is defined as what? The layout of this what? Cable system, like the cabling system, how it is laid out. So it defines the shape of what? Of your network. So, there are four principal topologies in the modern local area network that we'll cover here in more details. So there are four. So we have bus, mesh, star, and what? And the other. So let's look at the bus topology. One of the earliest methods of connecting pieces together for a LAN was the bus topology. It was the earliest method of connecting what? Pieces. The bus method utilizes a single cable, usually a coax, terminated at each end. Each network device, computer, printer, or other component addressable on the network. When they are saying addressable, it means it's connecting, it's communicating on the network. It has this what? IP address. Tap into the cable between the terminal ends. So it's like kukoksi wait makanga chikebo chimozi chachitali, and then my device ambanga jani connect between that cable, and at the end kwa cable makaja ni terminator uguso makasi jani terminator. That means majani ma computers ma printers also ambanga connect through that cable. Tingo ganiza ngati kuti chipajani tindi mtengo wa utaluja ali yesagwire mbali, and then at the end ukayani ukayiji tsulu uguso kayani ukayiji tsulu. That's it. Mapisa makayani amakala mbali with other printers and the what network devices. So the bus topology benefit comparison. Advantages is what? Inexpensive. It does not require additional hardware to interconnect the attached devices. There's no much cabling. Can't cable modes to just connect the pieces to that coax cable. Bus. So plasma cables in. Easy to install. Coax cable is durable and performs well in harsh environments. So we're saying coax cable in just room. It's also easy to install. You just press it and you connect the pieces. You are done. See, flexible. New device can be added by simply installing a new T-connector. See, what they are saying is a T-connector, the cable connect to coax cable with a PC. It's in the way you just connect the bagadi bus a T-connector with a PC. You can just install another device PC. You just this cable, then other topologies. You can see they just have one coax cable. The cables are T-connectors. They use this cables. First topology has also what disadvantages. Entire network shuts down if there is a what break in the main cable. You see, the cable imozi ngati cable imozi yapoyira cable imozi chikox chapoyira pena pake kuti chachaduka, and then the whole network will be down. Since the cable imozi imene panga connect chani ma device osiyani muyani topology yathu difficult to identify the problem if the entire network shuts down. Ngati network is down, you can know what the problem may be, since they are all connected to one what? To one coax cable, one thing. So imakabe over the uziwe good problem you get about. Performance. Coax technology is usually limited to a maximum of what? 10 Mbps. See, that is megabits per second. So that's the what? The maximum of what? Coax cable. The speed is what? 10 megabits per second. Not intended for use as a standalone solution in energy building. So as you can see, this is not reliable. You can't use it in building in Garuti Chokajo bus. See, it was some vulnerability like my breakings and the likes. You'll be having what? A downtime. A downtime in networking, you call it as the time when the network is what? Is not functioning. That's a downtime. So this of bus topology, bus networking. You see, we have these black things at the end. They are what? They are terminators, and the devices are at the what? In the middle. The computers, the save, and the what? And the printers. Those wires are connect from that cable to your PC. We call them what? T connectors. See? Our next topology, which is the second topology, is the what? The star topology. Star, as you can see, the star always starts from, it has a central point, the star, and it goes out from all the sides. Like star imakandi, pakati, and then imakandi maijezi, amazulira the stars. So the modern networks normally tries a star topology. The cables fan outward from what? Central network hub or concentrator. So the cables they run from what? The hub, like the central hub, and they run out to what? To the computers, forming a star like shape. Data on the star network passes through the hub or concentrator before continuing to its what? Destination. The hub or concentrator manages and controls all network functions, act as a repeater for the what? For the data flow. Okay, so in drawing we can put it as what? Can put it as this, as our what? this as our hub slash what concentrator. And these are the cables. They run out to the what? To the PCs. So at the end you will be having what? Having our PCs. All of this at the end. So it's like this. So they're saying what? The hub or concentrator, this is our hub, manages and controls all network functions like IP addressing, forwarding, and broadcasting. It manages. That's what the hub does. So acts as a what? As a repeater for the data flow. As a repeater, like it increases the speed of the what? Of the packet. As the packet goes from one PC to another, from this PC to this PC, like the speed is reduced. So the hub acts as a what? As a repeater to boost up the what? The speed to the what? This PC. So they're saying this type of topology is most common with twisted pair wires. So this is cabling type. We will learn this in the coming chapters. Although coax or fiber optic cables can also be installed star fashion. So figure 1 to 2 provides a visual representation of a star network. Table 1 to 3 describes the network benefits and what? And problems. So star topology benefit comparison. So we have advantages and what? Disadvantages. Advantage: easy to install. Each device on the network simply requires a cable run between it and the concentrator device. So it's just the PC and the concentrator. Just run the cable from the PC, from the device to the what? To the hub. That's it. See? Flexible. Devices can be added or removed without affecting the other what? The other device on the what? On the network. So we can remove one device from this without affecting the other computers. We can move this PC without affecting the other things here. So performance is greater with speeds capable of what? 10 Mbps to 100 Mbps or more. So our friend there, which was bus, it was just what? 10 Mbps. This one is giving us up to what? 100 megabits per second or more. Easy to detect faults and to remove what? To remove parts. Since each PC is connected what? Around. So we have the disadvantages as requires more cable than a bus topology. You can see there are more cables here. A bus topology just need one cable, coax cable. If the hub or concentrator fails, attached devices are what? Disabled. So if this fails, then all these what? Devices, PCs are what? Are affected. So more expensive than what? Bus topologies, because the cost of the what? Concentrator. Most of the concentrators, the hubs and the switches, they are what? They are most expensive. So you would opt for what? A bus topology because it doesn't need what? Much money. So twisted pair cables typically used in star topologies are not as immune to what? Interface as what? As coax. So that's it. This is a typical what? A typical star. You can see It has formed a star here. The concentrator is here. Then this printer, PC, and what, and the server. That's the typical what star topology. So next to be, we'll look at what mesh topology. The mesh topology is used primarily in environments where redundancy and high availability of every device is highly critical. With a mesh network, each device has at least 2 separate connections between devices. So many wireless networks are structured in a mesh topology. All devices on the network are directly connected to all other devices. So this is what they are saying is used where what high availability is what is needed and redundancy. So each device is connected to what? To another device, like it has many connections. So another example is a room full of people all talking to each other. There are 2 types of mesh topologies, the full mesh and the what? And the partial mesh. So a full mesh topology is created when every device on the network has a connection to every other device on the network. You can imagine each PC, each device has a connection to each and every what? Device on the network. You can see that it uses a lot of what? A lot of cabling. See, full mesh is generally expensive to implement, but use the greatest amount of redundancy. So in the event that one of the devices fails, network traffic can be directed to any of the what? Other devices. That's practical. Partial mesh topology is less expensive to implement and therefore offers less redundancy than full mesh topology. With partial mesh, some devices are what? Organized in a full mesh scheme, but others are only connected to 1 or 2 in the network. Partial mesh topology is commonly used, found in what? Peripheral networks connected to what? Full mesh backbone. So describes their benefits and what? And so this is what example of what? Of a mesh topology, a mesh network. You can see each device is connected to what? To another device, like it has many connections. See, this computer here is connected to this one, it connect to this one, connected to this one, and connect to what? To this one. So there's what? Redundancy here. And what? High availability of what? Of network resources. So we have the comparison of advantages and what disadvantages here. So mesh topology provides what? Redundancy and fault tolerance between devices and ensures the best possibility that the network is what? Available. Easier troubleshooting, guaranteed communication capacity. Disadvantages, there are only 2. Much more costly to install and maintain. You can see it's much more costly. There are many cables that you need to install, and to maintain you need to have what? Full knowledge of what? Of this networking mesh what? Topology. delays and extra processing time as a result of the communicating routing through intervening devices. So you can see this delay. There's always a delay. Like if you want to communicate, if this server want to communicate with this device, it will go through these old devices. This old device will go through this instead of just going what straight to this one, to this PC. So there's a delay of what communication due to what, to routing of what, of packets. So as you can see, this is an example of what our mesh topology. You can see each and every piece is connected to the other one. So it's kind of hard for this piece to go to this one, since it should go through this one, and then this one. So the routing is hard. So the communication is always delayed in what, in mesh topology, but it's effective and what provides what redundancy. So you have many pictures here coming on. You have this one. All this is what is mesh topology. Anyway, let's continue. So our ring topology. The ring architecture connects each device in a closed loop. Data signals travel from one device to the next in a single direction around the loop. A server in a ring topology is just one of several devices and does not provide routing functions. The most common type of ring topology is token ring, made popular by and almost exclusively found with IBM networks. Within a token ring, local area networks, each device in the ring is guaranteed an equal time slice to transmit data. Unlike other network methods like Ethernet, no device on a ring network can monopolize the communication of the network. ATM ring networks have two rings traveling in opposite directions to provide redundancy for the topology. Should one ring fail, data can simply transmit on the main ring. Table 1 to 4 summarize their benefits and problems. So the ring topology, like, it's easy to install and expand, better performance than the basic bus at higher levels of traffic, especially rings designed with fiber optic cabling, can provide guaranteed transmission time for each device on the line. So what they're trying to say is, when they're saying guaranteed transmission, is like computer area yose makandi ntawe yagiye done itumize data. Like there are 50 computers in the network using what, ring topology. Each computer we have is time to transmit data. So that time by the computer nenga bangi transmit data, ndama kwasa ntawe yago like time bangi transmit data. If tawe yago ya like sino bangi transmit data no yose, the other computer takes on. So computer area yose imakani ntawe yage, which means can't be flooding on the network. Connection is always what? Is always good. So we have the disadvantages here. More expensive than a what? Bus topology. Like the bus method, a break in the cable because it's a complete failure of the network. Network hardware for ring networks generally costs more than what? Ethernet components. So this is the ring. So it's like a ring, you see. So it's connected like a ring. Each computer, when it's transmitting, they will be silent. And then when this one is also transmitting, all these will be silent. Listening to what? To this one. So I think that was all about network topologies. If any question, welcome to us.